Hello and welcome to this .NET Nugget session. It's one in a series of short sessions where we spend 10 minutes or so looking at how we can do things with Visual Studio and the .NET framework. My name's Mike Talty and I work in the Developer and Platform Group at Microsoft in the UK. And this particular session is one of a series around the Windows Communication Foundation. So this is a technology for distributed applications. It's part of the WinFX. And in this particular session, I want to take a look at the sorts of different message exchange patterns that we can have between clients and services when we're distributing them with the WCF. Here in Visual Studio 2005, and I've got the September preview of WinFX installed, and I've just built two console applications as a client and a service, but we haven't finished them yet. And in the service here, where we're at is we need to define an interface. I'm just going to make this very simple. So we'll have an interface. We'll call it iPrint to console. And we'll just put a simple member on there. Let's call it print. And it's going to take a string to be printed to the console. And as we've seen before, we can have a service contract attribute on here to make this a WCF service rather than just a plain old .NET interface. And an operation contract on here to make this part of that service's operations. And the first sort of exchange pattern that we want to model here is the one that's indicated somewhat by this signature on this method. At the moment we have a signature which says there's a parameter comes in and nothing goes back. But in truth our contract doesn't represent that right now. The way to represent that in our contract is by saying that this is a one-way message exchange. And with that one-way message exchange parameter switched on, what we'll get is a slightly different WSDL document describing this service, and we'll get different behavior on the client than if we didn't switch this thing on. So if we just go and cook up a quick implementation of that, let's just write something to the console here and rip out this region code just to remove it from the screen. We've already got implementation that spins up a service host for my code and a config file which makes this thing available over HTTP. And if we were just to spin up an instance of this service and to ask it for its WSDL document, then we'd see that the service has this one operation here, print. And notice the only thing that's important here is there's only an input message. There is no output message. So we're just purely doing a one-way fire and forget kind of request across to this service. If we were just to run the simple client that we've built here, which just instantiates a proxy, calls that print method, and then prints out that it's done, then that client is not going to wait for this message to be processed by the service. And we can prove that to ourselves. If we wander back to the service for a second and just stick perhaps a big sleep in the middle of there, let's sleep for 20 seconds, build the service and the client, let's run the service. And if we just invoke the service from the client, you see that the client comes straight back and says that it's done, even though the service is having a 20-second sleep. That's how we can model simple one-way messaging. Of course we can do request-response messaging, so if we change this contract so it's no longer one-way, and we change this method so that it returns something back, so that's a message coming back as a response, and we'll have to change our implementation, remove the sleep for now, and let's just return thanks for calling to the client. Then if we update our proxy on the client side and rework the client code, so let's just visit this client code, and now this thing is going to return a result string or something like that, and we'll write that to the console. Let's just build that, make sure we're okay. And there's two things we'll notice now. One is that obviously if we start the service up, let's just debug that, and once again ask it for its WSDL document. Let's refresh what we've already got. You'll see that the service now has an operation that takes both an input and returns an output message. And of course if we were to go now and launch the client, then when the client invokes that service, it really is waiting for the service to respond back to it. I mean, in this case, the service is no longer sleeping, but if it did sleep, the client would have to wait while that happened. The other thing that we can do, if we just go and revisit our service code for a second, is that we can speak back to the client. So imagine that the client implements some interface I print confirmation or something like that. And on that client side we will send confirmed printing message of some sort back to the client. So we can mark this up again as a service contract, and we can mark this thing up as an operation contract. Clearly this is a one-way, so we'll just say so here. That's best to be explicit about that. What we can do is, using the WCF, we can say that this contract is the callback contract that is associated with our main service contract. So we're going to say this is iPrint confirmation. So what this is actually saying is that a consumer of this particular service, we expect them to implement this particular service back on their side of the conversation. And we can see how this is modeled through WSDL. It's interesting, if we build this code, which will build fine, and then we were to start the service here, let's just debug and start it, we should get an error from the WCF straight away. And what it's saying is that we're using a binding that doesn't support two-way communication. Not in this sense anyway. We have request response, that's fine, but we can't make a request and then send a response 20 minutes later. That's not enabled on this binding that we have. So what we need in our configuration to make this work is a binding that supports true duplex communication, where a client can send a message to a service and much later on a service can reply back to the client. HTTP request response won't really work like that. Now we've got the named pipe binding, that would work for this. We've got the TCP binding, but we've also got in the WCS a standard binding called the WS dual HTTP binding. And really what this is about is the client talks to HTTP endpoint on the service, but it also opens its own endpoint for the service to speak back to at any point where it likes. So we've got HTTP going in two directions from client to service. So if we were just to start up our service at this point, and if we were to ask it for its WSDL document, so let's just go and refresh this request here, then we'll see that the service actually gets a new operation here, confirmed printing. And on that particular operation we have a message only going outwards from the service, i.e. back towards the client, and that message is our print confirmation. So the way that this thing that we implemented on an interface here is modeled is that this message is viewed as going outwards from the service, and if we had a return type here, that would be viewed as coming into the service. So it's kind of like a reverse contract, specifying requirements we have on the client. Now in our server-side code, we can take advantage of this. So when somebody comes and calls our print operation, what we can do is we can speak to the operation context, which is a WCF helper object, get the current one of those things, and we can ask it to get us the callback interface. And in our case, that's going to be iPrint confirmation, which we just defined. And we'll get back an interface here, exactly as we expect. So let's call this confirm. And we get that straight back, and we can go and call that and say printing has been confirmed. And that's a message back to the client. Now if we do it sort of synchronously in line here, it doesn't seem very different from what we're already doing. But what we could do, we've already got a request coming in here and a response going back here. What we could do is move this to a different thread. So we could use, for instance, the .NET thread pool, and we'll queue up a piece of work, which will just make a quick inline delegate here. And what we'll do is let's have a sleep for 5 seconds, and then what we'll do is call back on that confirmation interface. So we get request, response, plus additionally 5 seconds later a confirmation call on that confirmation interface. To change the client side to work with this, we update our proxy, and then if we go and visit the client side code, what we'll find is that the proxy now takes a new instance of a thing called an instance context. So what we have to do on the client side is implement the callback interface. So if we go and have a class here, let's call this client confirmation, and we'll implement here this callback interface. And as we saw before, this has, as we just designed in fact, this has this single method on it, which is confirmed printing, and we'll just write that out to the console again. Let's have printing now confirmed. and we'll just put out that message. So what we need to do is provide an instance of this type to our proxy such that when responses come back asynchronously some later point in time on the callback interface, the proxy has somewhere to route those messages to. And the way in which that works is we define a thing called an instance context, make a new one of those, and we give it one of our objects that we just created, the client confirmation. And we just pass that into the proxy here. So we're saying that when a request comes back, route it through to here and print those things out. We need to amend our configuration on the client side, so let's just visit the client side configuration. We'll move this across to the dual HTTP binding. And there's one more thing we need to do here. The client is going to sit and listen for HTTP responses back from the service, so we have true duplex communication going on here. So what we need to do is just configure the client. Let's call this client config. And all we'll do here is add a binding for that WS dual HTTP binding. We'll set the name to be client config like we just saw, and we're just going to set the base address for the client. So when the client listens for HTTP coming back, we'll request that it listens on that particular base address. With all that in place, we should be able to go build client and service. Let's close a few windows. And if we run up the service, and then run up the client, and with our service listing, we'll just have the client invoke the service, and then the service is going to sit on that other thread for 5 seconds. The response has already gone back to the client at this point, and we'll see that the confirmations also go back to the client as well. So we had request response plus a callback interface of another response going back to the client at a later point. So true duplex communication going on between these two things. And as we said previously, for this interface that we've defined, which is kind of a callback to the client, we can go and deploy this service speaking this way over any of our transports that support this kind of duplex communication. So here we use dual HTTP. We could have gone and used TCP, which obviously does two-way communication, or named pipes, which does two-way communication as well. So as long as the transport is capable of doing something two-way, then you can take one of these two-way services and deploy it that way and get that kind of message exchange. Just to summarize what we've seen in this session, we've seen that we can do different kinds of message exchange. We can do one-way, we can do request response, and we can also do duplex that we just saw with that callback interface going back to the client. And in doing all of these, we just modeled them through service contract and operation contract, just like what we've seen in previous sessions, nothing magic to add to that. And we get the full power of doing these different exchanges of messages between different services. Okay, where would you go if you wanted to get some more information on the Windows Communication Foundation? Well, the best place to start is up at msdn.microsoft.com/winfx. And if you want to find some more information about the protocols, the web service open standard protocols that the Communication Foundation is capable of using, a good place to go for that would be msdn.microsoft.com/webservices. And that particular link we have on the slide here, /understanding, there's a great document there that specifies how all these things fit together to make a distribution platform as opposed to just a random set of specifications. And finally, if you want to follow up with anything you saw in this little session, feel free to drop me an email. My address is there on the screen. It's just mtolty@microsoft.com. Other than that, thanks very much for listening.